This unit we will start with the concept of friction, and I will assume that the basics of friction are completely known to you. When I say basic, I mean that what is coefficient of friction, and then the simple things, for example, the laws of friction. So those are assumed to be known because that comes under the syllabus of 12th standard. So I assume that all of you have done that before entering here. So that is assumed. And just one point which I will emphasize here is that okay, all of you have okay, let me start with this example. Suppose there is a ground here and we have a mass m and coefficient of friction. So now when I say you know the basics, I also assume that you know the difference between static coefficient of friction and dynamic coefficient of friction and angle of repose. All those things are assumed to be known. Okay. Now under these conditions, suppose you apply a force here, okay, and then if we are looking for the frictional force which is there, then all of you know that as we increase the force from 0 upwards, okay, we increase it, then so here I am writing the frictional force, okay, and this side I am drawing the force which you are applying, the applied force. Okay. Now when the applied force is 0, the frictional force is also 0, and when you increase the force, so basically you increase it, the frictional force also increases. In fact, this should be exactly same as that. It should be in fact 45 degrees sort of, okay. That means this force will be equal to frictional force, and then something like this happens, and even if you increase the force, the frictional force will remain constant, and all of you know that why this kink is there and what is the meaning of that. Basically from here the static friction ceases to stop and the dynamic friction or kinetic friction starts to come into picture. Okay, so now and then for all our practical purposes, almost every time we will assume like this, okay. This kink we will not be so bothered about, but at some cases if explicitly it is mentioned, so you have to think about it. Otherwise we are just if nothing is mentioned, so you should assume that this is the way the friction acts, okay. And yeah, now when you think about this, generally the students have they have a tendency, which is not wrong, I am not saying it's wrong, they have a habit of thinking in this way, that there is a normal reaction, okay. So let me do one thing, this this is not done, so okay, I'll draw it again. I just wanted to have this, okay, mass is here, and yeah, so this is like that, okay. And now what I was trying to draw was, So mg acts like this, okay, and you have this habit of thinking that this normal reaction acts like that, and if I am trying to move it like this, so then a frictional force which acts here in this direction, right. So that's the normal way, and then this frictional force will be equal to mu times n, okay, when it is just about to slip, on the verge of slipping, when it is there. So you equate this with that, and before that point is reached, you have this F is equal to Fr. So that's the idea. Now that's good enough, but then for our discussion in this course, we along with this is important, I am not saying this is not important, along with this view, another view I would like you to always keep in mind, and that view is to combine them. Means, see, these are like the component representation of the reaction from the ground, and I am now thinking about the unit vector representation, sort of, okay. That means angle theta and reaction R. So this interpretation of the same thing, so these are component form, these are unit vector form. So in this direction, that is some angle theta, if you think of an unit vector, and magnitude is R. And when you think about this, you should also think that like in this component form, you always visualize in how do you visualize? As soon as we increase F, this Fr gets increased, right? This N remains constant because N is equal to mg, this remains mg, and this part gets increased. So that is how you visualize in the component form of representation. And in this unit vector form of representation, we will think that this vector just moves around, okay. The reaction is rotated about, when force is 0, it matches with n, and when you increase the force, this vector moves in this direction, okay. It rotates, and then it stays at a particular angle, it does not go beyond that, okay. So even if you increase, once you reach that point where it saturates and then it starts moving, it is on the verge of moving, then at that location it stays, it does not go beyond that, okay. So that's another viewpoint which we will see that how it is going to be very, very useful. This interpretation also of the same physics will be very, very important. Now, so that was one thing which I wanted to just make explicit before we proceed, and I know that this also you have studied, but I just wanted to make it explicit. Now, in this subject we will be talking about, because it is an engineering course, we will not study friction as just a concept, but we will apply this in use, okay. Means some engineering applications we will see, and in fact we will see 3 applications in a way, and they are all sort of power transfer. Means friction is used to transfer some power or do some work. So these are the things which we will do. So in fact, if I want to list out, so one is, we will discuss wedges, then we will discuss screw threads, okay, square type. Well, we'll come to that. And like, you know, pulley drives. So these are the three concepts or applications of friction which we will primarily be discussing under the topic of friction, okay, because these are engineering applications. Yeah, generally when I say this, students are okay with these two, okay, these two they are okay with, but then they think why a wedge should be called, you know, a device or an application, engineering application. So the point is, I also agree that wedge in itself is not a very useful application or a gadget for that matter, but why we are studying wedges is that will lead us to the discussion of screw threads. Why I am saying that is, see, let's start with even the wedge. Just I am introducing, I am not going to discuss the maths of the wedges here. I am just discussing why they are important and what is the relationship of these wedges with the screw threads. And then in the next segment actually we will formally start with wedges. Okay. Now suppose you want to, and all of us know that this method of lifting probably was being used by people when the machines were not there. So this probably was a machine when people wanted to say lift something like that. It's bad. Say, hurry. Say this one. Suppose I want to lift this one, then what I will do is, suppose I put some stoppers here, rollers, okay, and then on the ground, say on the ground, let me complete this. So suppose this is the ground and I wanted to lift this block. Let me say this is, say, a block of mass m and this is some small mass m maybe, and now what we can do, or what people used to do, I think, is then apply a force from here. Okay, you apply a force and then keep a stopper sort of thing which has almost no friction at this end, then see what happens. So now if this block comes here, this block will go up. So this is a simple gadget which can be used to move any mass upwards. But the thing is, okay, if we want to use less and less force, then the requirement will be to decrease this angle alpha. If we decrease this angle alpha, with little force we can lift off this mass m, okay, though the means longer time will be required or longer distance. Actually I was coming to this point, that to increase the height of this body from the ground, for the same amount of increase of the height, if the alpha is reduced, then you will require a longer wedge, right? But with lesser force, if you are having low amount of force which is available, then you can use a lower alpha wedge and still you can lift it off, okay, slowly, but you can lift off. So now then that means if I draw a smaller angle alpha, so maybe it will go like that, okay. So okay, like that. So to go up to the same height, now I am requiring a larger length of the wedge. So this way of lifting things was done for a long time before somebody might have thought that why not do a better way of reducing the distance which is required. Okay. Now what is the solution? So what they did, let's say I'll go to another page. Say suppose we have a wedge. I'm just drawing a wedge. Say yep. Now so I have this wedge. Now maybe yep. So this is the wedge which I have, and then okay, let me draw in 3D. So this is the wedge which I have, and then what I do, I'll take a cylinder. Okay, say a cylinder, and I will try to wrap this wedge about this cylinder. Okay, so what will happen is, if I wrap it up, so I'll start from here, then from here it will go on that side, so it will just go on that side and this will go on that, and when it comes to this side, maybe it will come over here, and so something like that will be there. Okay, so like that, and the wedge will look something like that. Okay, so let me try to erase some parts so that it will be slightly more understandable. Okay, now yep. Okay, so now like that, I have wrapped it up, this wedge. Then in doing that, what I have achieved is, what I have achieved is, so this is, yeah. Now instead of pushing, I'll have to turn it. Okay, so if I say about this axis, if I turn this, then it is as good as pushing the wedge here. In the previous one, my pushing the wedge is equivalent to turning this, so this yellow thing, the wedge, is now completely fixed to this cylindrical shaft. Okay, it's frozen, it's attached to that, and if I turn this, it's as good as moving it. For example, suppose now I have a body here. Okay, let me try to draw it. I don't know whether I'll be able to say suppose some body like that, maybe a cylindrical body maybe. Okay, now suppose this is a kind of body which is there, and if I can support this side by some means, and if I rotate it, in fact the opposite way, say yeah, so I'll move in this way, not the other way, so I'll erase this. If I rotate in this way, then what will happen? Just try to imagine. Okay, so and then I have kept some stopper on this side, on this side I have kept some frictionless surfaces so that it will not slide, and then I'll rotate this block. Then don't you think that this part will come into as if I'm pushing from that side, and this part will lift off, this purple part. So that's the conversion from a wedge to a screw thread. So a screw thread is nothing but a wedge wrapped around a cylindrical shaft. So that is how we will discuss. First, that's the reason basically why we will spend some time. In fact, one segment we will be spending on the wedge itself, and then we will move on to discuss screw threads, and then we will definitely get into the belt drive or the pulley belt drive. So with that small introduction and discussion on the topics which we will be covering, let's stop here and see you in the next segment.